Hello and welcome to Mr. Davis's classroom. This is Algebra 1. Today we're going over lesson 8-7, and this is part 2. Today we're covering the difference of two squares. Last time we covered factoring perfect square trinomials. Today we're doing the differences of two squares. All right, so let's get into it. Difference of two squares is a little bit different. In fact, that it's only a binomial to start with. We only are going to be working with subtraction signs, right, for the original problem. And each part has to be a square. Right? So an example would be like this one right here with x squared minus 64. Okay? So the difference of squares part, so we have the difference, tells me subtraction sign, check, I got a difference, of two squares. Well, it's easy to see that x squared is a square. Is 64 a square? Well, 64 is 8 squared. When we have two squares like this, the answer can be written as simply as x, the first two terms, 8 as the second two terms, and one's a plus, one's a minus. And it doesn't matter which way you put it, first or second, but it's going to look like that. All right, so let's move forward and try one out. So here I have a problem that I want to try to factor out. First thing I notice is that there's only two terms. Now, since there's only two terms, that should give me a very, very strong clue that I should be trying to use difference of two squares. Okay? So the first thing I need to do is check to make sure each one of them is a square. So z squared is obviously a square. Is 9 a square? Well, 9 can be written as 3 squared. And of course, we have a minus sign that tells us that it's a difference of two squares. If there was a plus sign there, couldn't do anything about it. But since there's a minus sign, we can. So since I have two squares, I can rewrite them. First term goes in the first of each one. Second term, second. And then we have a plus and a minus. So that's the difference of two squares. Now, I'm going to relate this back to factoring from what we originally learned, okay? So let me erase this. I'm going to rewrite this difference of squares problem just a little bit. So I have z squared plus 0z subtract 9. Okay, so I added in this 0z part because we don't have any of those in, but I'm going to leave it in there as a placeholder. If I'm going to do x factoring, I need to multiply to get -9, add to get 0. So because I need to add to get 0, I know that both of these terms have to be the same. So I need to think about what two numbers multiply to get -9. 3 and -3, and 3 plus a -3 is 0. Then when I plug those in, I get z minus 3, z plus 3. Same type of factoring there. The only difference is using difference of two squares formula will get you there a little bit quicker, a little bit of a shortcut. But again, you know, if you're set on one way of factoring, you like the x factoring, and that's all you want to do, I'm okay with that as long as we're getting the correct solutions. All right, here's two for you to try it. Please get these done before moving forward. All right, now here we have one. The difference here is we have an extra number in the front, so we need to see how that changes it. Well, there is two terms here. Gives me a clue that it's difference of two squares. There's a minus sign, it's another clue. I know that the second part I can write as 9 squared. But this first part, I need to think to myself, the x part is pretty obvious, but can 16 be written as a square as well? And the answer is yeah, we can write that as 4x squared. And when we write this, we always put that inside the parentheses. Right? Then, since it's the difference of two squares, we can write the first term twice, the second term twice, one addition sign, one minus sign, and we are done. Okay? This is a lot nicer than if we tried to factor it with previous methods, because we'd have to use AC factoring. But, you know, this is a little bit of a shortcut. But if you need to use AC factoring, That would be okay. I'd strongly recommend learning this method though. All right, here's one for you to try, and please try A and B before moving forward. All right, now I get to a problem like this, okay? First thing I see is two terms. Tells me, hey, I should be thinking difference of two squares. I see a minus sign, I'm thinking great, I'm well on my way, but then I get to looking and I say, ooh, I have a 6 and I have a 24. Those are not perfect squares. Those aren't perfect squares at all. Well, one thing that we can look for is the GCF, right? The greatest common factor. So I have 24 and 6. What goes into both of those? Well, I think 6 goes into both of those. Now I want to see, do I have perfect squares now? Well, for g squared, I think that we can see that's going to be 2g squared, right? 4 is a perfect square, g is a perfect square, we're all right. We have a minus sign, and 1 is 1 squared. So we do have a difference of squares, so we'll rewrite that as 2g plus 1 and 2g minus 1, okay? So if it looks like a difference of squares problem, but you don't have perfect squares, you should be thinking about the GCF. Here's two for you to try. All right. Remember to think about GCF first. All right, here's your homework on page 515. I'd like to say thank you for stopping by Mr. Davis's classroom.